The Air Data Inertial Reference System provides flight data such as position, speed, altitude, and attitude for the flight displays, flight management computers, flight controls, engine controls, and other systems requiring inertial or air data. The major components of the Air Data Inertial Reference System are Air Data Modules, the Air Data Inertial Reference Unit, or ADIRU, and the Secondary Attitude Air Data Reference Unit, or SARU. The ADIRU is the primary flight data source, while the SARU acts as an automatic backup to the ADIRU. The SARU is the dedicated data source for the standby attitude indicator. First, let's look at the air data part of the system. The air data modules are remote sensors which electronically supply pitot and static pressure information to the flight control's data bus. The air data modules receive and process data from 3 pitot probes and 6 static ports, 2 per module. 2 standby modules provide dedicated inputs to the standby airspeed indicator and standby altimeter. The ADIRU and SARU receive 3 independent bus inputs to calculate airspeed, Mach, altitude, and other air data parameters. Both units independently compare the inputs and validate which signals should be used in their calculations and other displays. The ADIRU and SARU also receive data from 2 angle of attack sensors and 1 total air temperature, or TAT probe. TAT is displayed on ICAS. Now, let's examine the ADIRU in more detail. The ADIRU is a single fault-tolerant unit which replaces the inertial reference units found on some airplanes, or the mechanical gyros and inertial navigation systems on older technology airplanes. The ADIRU contains electronic sensors and non-mechanical laser gyroscopes which measure airplane movement in all 3 axes. Signals from the sensors and gyros are used to calculate the airplane's attitude, heading, ground track, ground speed, and the airplane's latitude and longitude position. Before the ADIRU can calculate this information, it must accomplish a pre-flight alignment. Pre-flight alignment is the calculation of the airplane's relationship to true north and is done independently of any navigation aids. During alignment, the sensed gravity force is used to calculate the airplane's attitude, and the Earth's rotation force is used to determine the location of true north. The airplane must remain stationary during pre-flight alignment to properly sense Earth gravity and rotation. The process takes from 6 to 15 minutes, depending on latitude. Delay pushback or taxi until alignment is complete. To maintain navigational accuracy, a complete alignment is recommended if the time between alignments is expected to exceed 24 hours. Alignment begins with the ADIRU switch. The ADIRU switch is located here on the overhead panel. To realign the ADIRU, the switch must be left in the off position for 30 seconds and then pushed on to start a full alignment cycle. Primary electrical power is available. Position the ADIRU switch off and back on. Verify that the off light is extinguished. The EICAS memo message EASA&DCAA Align Mode displays while the alignment is in progress. The only information the EASA&DCAA needs from the flight crew is the airplane's present position. You will learn in another lesson how to use the FMS CDU to enter your present position. The crew enters the most accurate present position available. If global positioning system coordinates are available, they are the most accurate. The EASA&DCAA compares the enter position with the current GPS position or with the last known EASA&DCAA position and the sensed geographical latitude. The FMC also compares the enter position against the coordinates of the active flight plan's origin airport. When the alignment process is complete, the EASA&DCAA enters the navigate mode, and the EASA&DCAA Align Mode memo message is removed. Although the EASA&DCAA is very accurate, after entering navigate mode, errors accumulate. To compensate for this, the FMC calculates its own position using both EASA&DCAA position and other data. To provide navigational backup in case of dual FMC failure, the EASA&DCAA contains an identical magnetic variation table. Variation data for all locations between north and south 82 degrees latitude, except for some areas near the magnetic poles, is stored in both systems. The FMC is covered in detail in other lessons. System logic prevents the EASA&DCAA from being depowered if the EASA&DCAA switch is inadvertently turned off in flight. When the airplane is secured, positioning the EASA&DCAA switch off prevents discharging the main battery when AC power is removed. Position the EASA&DCAA switch to off. Verify that the switch shutter display is blank and the EASA&DCAA off light illuminates. If the EASA&DCAA switch is left on when power is removed from the airplane and the battery switch is off, the on battery light illuminates. And the ground crew call horn sounds. Before we discuss an EASA&DCAA failure, let's first look at its backup, the SARU. If data from the EASA&DCAA becomes invalid, the SARU automatically provides flight critical data to the same systems. The SARU provides speed, altitude, and attitude. The SARU, however, cannot perform inertial navigation functions. The FMC route map will be lost if GPS data is not available. The SARU can only provide a temporary heading reference, which is discussed next in non-normals. The EICAS caution message, Nav EASA&DCAA inertial displays. If the EASA&DCAA is not capable of providing inertial navigation, attitude, heading, track, or ground speed data. On the ND, track and position data are provided by the GPS. Heading indications remain displayed for 3 minutes after the message appears. When the heading indications are removed after 3 minutes, the set heading line appears on the position initialization page of the CDU. On the PFD, air data and attitude indications are provided by the SARU. flap maneuvering speeds cannot display. After 3 minutes, heading indications are removed, and most roll and pitch modes are no longer available. To regain the heading displays, the crew must enter a SARU reference heading in the set heading line. Enter a heading of 127 degrees. The entered heading remains displayed for only a few seconds. Heading information is restored. The entered heading must be periodically cross-checked against the magnetic compass and updated as necessary. Cancel the ICAS message. The CDU scratchpad message Enter Inertial Position displays if the EASA&DCAA has completed its initial alignment process, but no position has been entered. The same message displays if the entered position fails the comparison check against either the GPS position or EASA&DCAA sensed latitude. The realignment initiated message displays if the same position which failed the EASA&DCAA latitude check is re-entered, or an internal problem is sensed during alignment, such as the airplane moving. The inertial origin disagree message displays if the entered position is more than 6 miles away from the location of the FMC active origin airport. Entering the correct position allows the EASA&DCAA to complete its alignment. This completes the instruction portion of the Air Data Inertial Reference System lesson. It has been more than 24 hours since the EASA&DCAA was last aligned. Realign the EASA&DCAA. How long must the EASA&DCAA switch remain off? Try again. Try again. Complete the alignment procedure. Select the displays that show EASA&DCAA information after alignment. You've touched this before. Make another selection. You've touched this before. Make another selection. 7 displays can show EASA&DCAA information. Touch the highlighted area. You've touched this before. Make another selection.